Hello children, welcome to Yamuna's Physics classes. Today we are here to discuss the topic 10.3 of the lesson Wave Optics. So in the last class we have discussed in detail what is Huygens principle. So in this section what we are going to do is, using Huygens principle we are going to underline what are the laws of reflection as well as refraction. By Newton's corpuscular theory in last lesson ray optics, you know that what is reflection law and law of refraction. Law of refraction means Snell's law, that is sine of an angle by sine I by sine R is equal to refractive index or optical density, and that is same as ratio of the velocities of the medium that we have studied. And in reflection, you know, the angle of incident will be equal to angle of reflection. So these two are that done by Newton in corpuscular theory. The same thing in this topic we are using Huygens principle to derive those things. So let us see how it is. So the figures are exactly same in NCERT, and it is very clear from the figure itself. Everything I have written on the board, it is detailed. But even then I can explain in my own manner. So let us see how to explain this figure. In this I just want to recollect what is Huygens principle. Huygens principle says that on a wavefront you can have each and every point of source of secondary wavefront. They can produce secondary disturbance, and then the wavelets originate from that secondary sources, creates secondary wavefront. So that was the important word of Huygens, the concept of wavefront. So we need that concept to explain both of it. Now let us see. So here the wave, it is very clearly written, A dash A, B dash B are the two incident waves. And one more thing, always the wave and the wavefront, the directions will be mutually perpendicular. They will be 90 to each other. So if this is the incident wave, this is the 90-degree wavefront of the incident wave. So AB shows the incident wavefront. A dash, B dash shows the incident wave. Hope incident wave and wavefront are clear. They are 90 to each other. Now, it is coming and falling on a surface XY. This XY is a surface which separates the two medium 1 and 2. Medium 1 has a velocity v1, medium 2 has a velocity v2. And this is rarer medium 1, denser medium 2. So velocity of the light in the second medium or the denser medium is lesser compared to velocity in the rarer medium. That we know. If you check the refractive index, you know the values are like that. The value of glass 1.5, water 1.33, you know all these values. So from that we can understand which is rarer, which is denser. So when you go from rarer to denser, at the denser medium, the velocity is lesser than that in the rarer medium. Okay. Now come back. So we know incident wave, wavefront are 90 to each other. Now, incident wave is falling at the point A. It falls at the point A at a time t equal to 0. At the time of falling, let the time will be 0. But meanwhile, when the incident wave falls here at the point A, that particular source at the point A has already completed medium 1 and is going to medium 2. But at that time, this wave, the wave source at the point B, has to travel an additional length BC before it comes to the medium XY. So let that time be tau. By time t equal to tau, it has to travel the distance b to c. So if v1 is the velocity, the distance obviously is v1 into tau. You know distance is velocity into time. So v1 tau is the time taken by the source at the point B to come to the medium xy. It just reaches the medium xy after a time tau. Meanwhile, with the same time tau, already that wave which is at the point A will go through the second medium, refracted, and travels through the second medium through a distance v2 tau. Why v2 tau? Here it takes tau time. By the same time tau, the point A creates disturbance and it advances through the medium whose sphere of radius v2 tau. But v2 is lesser than v1. So BC will be much greater compared to AE. AE is the distance travelled in the second medium. BC is the distance travelled in tau time in the first medium. So v1 tau and v2 tau, you have two values. v2 tau is lesser than v1 tau. Okay. Now at that point it comes to the point E, suppose, and from C you are creating a tangent to the sphere so that it strikes the point E. So we will have CE as the refracted wavefront. CE is the refracted wavefront, and AE dash, this thing EE dash, CC dash comes as the refracted wave, not reflected, refracted wave. So refracted wave advances like this, parallel to each other. Now this is the refracted wavefront. So again, physics is over, next is maths. From the figure you can find out which is I, which is R, take the ratios, over, done. So if this is I told you incident wave and incident wavefront are 90 to each other. So obviously this will be 90 minus I. So if this is 90 minus I, normal and the surface again makes an angle 90. So this is I. So this is I. Similarly, look at R. If this is the normal at the point, this is the plane of separation. Refracted wave and the normal makes an angle of refraction R. If this is R, the remaining is 90 minus R. Again, this will be 90. Why? Refracted wavefront makes an angle 90. Refracted wavefront, refracted wave, the angle is 90. So if this is 90 minus R, for sure this will be R. So you have the value R. Now from the figure, triangle ABC. What is triangle ABC? ABC. Look at the triangle, this is 90. AEC, this is 90. So from those two triangles, ABC, what is sin I? Sin I, opposite by hypotenuse. Opposite is V1 tau, hypotenuse is AC. Similarly, AEC, what is AEC? AEC. This is hypotenuse, this is opposite. So what is R? Opposite V2 tau by AC. Take the ratio sin I by sin R. Sin I by sin R you can take, AC cancels, tau cancels, same time. So the ratio will be V1 by V2, and V1 by V2 is again a constant. By V1 is a constant, V2 is a constant. So the ratio will be again a constant, and that ratio is known as refractive index from 1 to 2. So you will write N1 2, going from 1 coming to 2. So this is known as Snell's law. So Snell's law is proved by method of Huygens principle, or using Huygens principle. Huygens principle means the concept of secondary wave source and secondary wave front. Clear? Now if this part is clear, you can just understand this, need not explain. But still I'll explain. Now look at this. What is happening? Here you have only one medium. So what's the main difference between the two? Here you have two medium because it is refraction. This is single medium because it is reflection. That's the main thing. And one more thing, you have a medium whose velocity is v. The velocity is v. Similarly, whatever you have drawn, the same thing I have drawn here with a small difference. This is a small difference. You don't have to medium. This is reflection. So it cannot pass to the second medium, only remains in the first medium. So come here, A dash A, one wave, B dash B, second wave. These two waves come and fall on the surface XY. At the point A, when t equal to 0, A dash A have already come to the medium XY, but B dash B again has to travel V tau time. Sorry, tau time, V tau distance. It has to cover V tau distance to reach C. So the wave at the point B reaches, or you can say here, the source. All these points I told you are sources. This source makes wavefronts of V tau radius before it reaches the point C. And by the time the wave from B reaches C, it will take a distance V tau, a time tau. By the same time tau, the wave which has already come to the point A goes back with the same radius V tau. Here, that's an important thing. It has both has the radius V tau, but here we have the radius V1 tau and V2 tau. Why? Here you have the same velocities because the wave is getting reflected to the same medium. So no change in velocity. So if you have a compass and pencil, maybe you can draw a better diagram. The same radius will be here again. So as it travels V tau distance, the same V tau will be here again. But here you can see there is a minor difference. So this is same as AE distance is same as BC distance. That is V tau. Same distance travel just because they have same velocities, same medium. Now the remaining, you can very simply show the triangles AEC and ABC are congruent. How? This side same. AC is common to both. Also this angle E, this angle B is 90. So obviously angle I equal to angle R because these two triangles are congruent. Congruent in the sense they have two sides are same. That is for the triangle for the angle AEC and ABC, the two sides AC are common to both. AE and BC have the same values. Two angles are 90. So for sure the other angle I should be equal to angle R. And you know, by law of reflection, the angle, this is R. What is R? Incident ray and the normal, that is I. Reflected ray and the normal, that is R. I equal to R. From this triangle, we can prove that angle I is equal to angle R. Means whatever be the angle of incidence, the same will be the angle of reflection also. This is again proved by Huygens principle. Hope it is very clear for you. Everything have drawn on the board. You can take down, learn it. Then go through the NCERT text. Hope it will be clear. Thank you for listening. Thank you.